All right, let's jump right in. Today, we're going to talk about the one piece of tech that basically runs all of modern AI, from the chatbots you talk to the tools that generate images. This is the story of the Transformer.
So, have you ever stopped to think, how exactly does something like ChatGPT or Gemini seem to, well, get it? How do they understand the context of what you're saying, the nuance, the jokes?
Well, believe it or not, the answer really comes down to one single, totally game-changing paper from back in 2017. It wasn't just an improvement, it was a complete paradigm shift that changed everything.
Okay, so to really get why this was such a big deal, we need to rewind the clock a bit, back to the world of AI before 2017. Their biggest headache? Figuring out how to process data that comes in a sequence, like the words in a sentence.
See, back then, the main way AI models worked was with something called a recurrent neural network, or an RNN, and they basically read a sentence the same way you or I might, one word at a time from start to finish, trying to remember what came before.
And this visual really nails the difference. On the left, you've got that old RNN approach, this slow, step-by-step chain. But on the right, that's the Transformer. It looks at every single word all at once, in parallel. I mean, that was just a completely different way of thinking about the problem. So this old way of doing things, it had a couple of huge problems. First, man, was it slow. Processing word by word just couldn't take advantage of modern computer hardware. And second, its memory was, well, it was terrible. By the time an RNN got to the end of a long paragraph, it had pretty much forgotten what the beginning was about.
So, you can see the problem, right? The whole field was kind of stuck. They desperately needed something new. Something faster, something that could actually remember context across long distances.
And then, in 2017, it happened. A team of researchers from Google dropped a paper that would change everything. The title alone was just so bold. Attention is all you need. And with it, they introduced the world to the Transformer architecture.
The idea they proposed was, well, it was kind of nuts at the time. They basically said, let's just throw out that whole one word at a time thing. Instead, they built a brand new architecture based entirely on this one mechanism called attention.
This table, which is actually from the paper itself, shows you exactly why this was so brilliant. Look, with the old recurrent models, the farther apart two words were, the harder it was to connect them. But with self-attention, the distance is always just one step. Any word can talk to any other word, instantly. It solved the speed problem and the memory problem in one clean shot.
Okay, so what is this attention thing really? How does it actually work? How does a model figure out what's important when it's looking at everything all at once?
Right, so the heart of the Transformer is this idea of self-attention. Just think of it like this. For every single word in a sentence, the model can look at all the other words and ask, okay, which of you guys are the most important for understanding me right now?
Here's a quick breakdown of how it works under the hood. For each word, the model creates three things: a query, a key, and a value. The query is like the word asking a question. It then compares its question to every other word's key, which is like their available information. The better the match, the higher the score. And those scores determine how much attention the word pays to the others, pulling in context from the most relevant words to shape its final meaning.
This makes way more sense with an example. Take the sentence, the animal didn't cross the street because it was too tired. Now, what does it refer to? The street? No, of course not. Self-attention is what lets the model instantly connect it all the way back to animal and tired. It sees that relationship right away. That's how you get that deep contextual understanding.
But it gets even cooler. The Transformer doesn't just do this once. It uses something called multi-head attention. It's like having multiple little attention mechanisms running at the same time, all in parallel. Each head can learn to focus on different things. One might look for grammar, another for who did what to whom. It's like looking at the sentence from 8 different angles all at once.
Okay, but wait a minute. If the model sees all the words at the same time, how does it know what order they're in? I mean, the dog chased the cat and the cat chased the dog have the exact same words, but the meaning is completely different, right?
The solution is just so clever. It's called positional encoding. Before any words even get processed, the model adds a little piece of information to each one. You can think of it like a GPS coordinate, a unique signal that tells the model, hey, this is word number 1, this is word number 2, this is word number 3, and so on. Problem solved.
So you put it all together, that powerful self-attention mechanism, and the clever positional encoding, and you've got the transformer architecture. And its impact? It was, and I'm not exaggerating here, immediate and absolutely massive.
I mean, just look at this timeline. The paper comes out in 2017, a year later Google drops BERT, the next year OpenAI releases GPT-2, and then boom, by 2022, ChatGPT makes this technology a household name. The pace was just breathtaking.
And today, it's not even a question. The transformer isn't just an architecture, it is the architecture. You name a major large language model, Google's Gemini, OpenAI's GPT series, Anthropic's Claude, Meta's Llama, they are all built on the same fundamental ideas from that one 2017 paper.
The AI pioneer, Andrew Ng, summed it up perfectly. He said, the transformer is for language what another architecture, ResNet, was for computer vision. It wasn't just an improvement, it was a total reset that started a whole new era.
So when you boil it all down, by cracking those two huge problems, speed and memory, self-attention unlocked the ability for these models to get bigger and bigger and bigger. It's the reason AI can do the incredible things we see today. And it really just leaves you wondering, right? If attention was the big breakthrough of the last decade, what's going to be the next one?